What we have here is a simple Excel calculator to compute the critical lift rate. Now, I provide a bit of theory in this first tab, where you can see a couple of links as reference to see where the formulas used came from. And you notice I have a Turner section and a Coleman section. Those two are the two most industry widespread correlations used to compute the critical velocity. And there's a 20% difference in the factor used only, but essentially the formula is the same. And both obviously are based, as you know, on the balance between the gravity and drag forces. So the critical velocity essentially is the minimum velocity needed in the gas flow stream to lift a single liquid droplet. Now this obviously depends on the fluid properties, depends on whether this is a water droplet or an oil or condensate droplet. You can see a surface tension input in the formulas. And the experimental factor, as I said before, there's a 20% difference between Turner and Coleman. So you can see a bit of wording here to explain those two. But then really what you need to do is to come to the calculator tab and enter your inputs in the yellow cells. So these are user inputs. The blue cells are calculations. So these are formulas that you shouldn't be touching. And as you notice, some of these are PVT correlations. So these are actually Excel functions that are coded in the underlying VBA correlations library, which I provide unlocked as part of the workbook. So you can come here and see the actual PVT formulas or functions being used. You can inspect them and even you can edit them if you feel like using different PVT correlations. But you don't need to worry about these are actual functions in Excel, which you can type and use as any other Excel function. So if we come here and start just typing our inputs into the yellow cells, for example, 500, let's increase the temp to 200, specific gravity 0.6. The liquid is provided as a list where you can simply select whether it's water or oil or condensate. And the correlation again as a list where you can simply choose whether you use the Turner or the Coleman correlation. The tubing ID is needed to compute the cross-sectional area because from velocity you compute the rate from that cross-sectional area input, and this is calculated as a function of that tubing ID. So again, just to simplify your life, I provide a list of industry tubing ID denominations. You simply select the tubing ID by selecting from this list, and then the results are presented in this chart, which plots the critical rate as a function of pressure. That pressure is the one that is currently sitting in this cell, but I also provide this slider for you to simply drag and see how this updates in real time on the chart. So you can see a bit of a label on the chart itself with the value of the critical rate for that prevailing pressure value. Okay, and the title also specifies which is the correlation used in turn, as well as the liquid type. So if I change this to water, it updates to water there. And if I change the correlation to Coleman, the title updates to Coleman. So the chart itself shows you exactly everything you need to know. This is the critical rate for that prevailing pressure value using the Coleman correlation for a water droplet. Okay, again, once more, the underlying VBA correlations library tells you what are the PVT functions being used in the workbook. So you can come here and inspect those formulas and even edit them if you feel like using different PVT correlations. That's it. Let me know what you think. Cheers.